my name is Jalen Mason. I'm a junior computer science major, and I will be going over my presentation for our midterm final project based on content-based image retrieval, based on query by example, QBE. Our table of contents, I will be going over background information, use cases, literature review, methods, results, my conclusion, then my references, of course, and then finally I'll end off with a demo. What is content-based image retrieval? When we talk about image retrieval, content-based image retrieval represents the paradigm shift from traditional keyboard search to a visually driven approach. Unlike conventional methods that rely on textual description, CBIR delves into the inherent visual characteristics of images. By employing sophisticated techniques, CBIR systems extract featured color histograms, texture patterns, and even object recognition capabilities by using deep learning models. This comprehensive feature extraction allows for CBIR to capture the essence of an image, transcending the limitations of descriptive regular data. This empowers users to submit a query image and retrieve similar images from a database, even if the target images lack a descriptive label. Image searching for a specific fashion style by submitting an image of a garment, or just seeking for home decor, as I'll delve into more with the use cases. These applications honestly extend farther beyond personal use, proving to be valuable in fields as regular photo retrieval or medical images for analysis and anomaly detection, or even for law enforcement, as I said I'll get into later. We can expect more sophisticated feature extraction techniques and more similarity measures to emerge, further enhancing the effectiveness and versatility of this innovative retrieval approach. Like I said earlier, the use cases that we could use content-based image retrieval in basic image search engines, of course in digital asset management and fashion, crime database analysis and art. The two that I wanted to briefly talk about, the fashion and crime database, you could easily scan people's, when the user were to input for any image they could upload a picture of a shirt, and of course the CBIR framework would return any images on the internet that match whatever the user could be looking for. In literature review, we talking about the key findings and the impact and where I think the CBIR can head in the future. Usually, feature extraction for CBIR relies on handcrafted techniques like histograms or texture analysis. However, the recent advancements in deep learning have revolutionized this field. Deep CNNs, or convolutional neural networks, have the remarkable ability to learn visual features directly from image data. By training a CNN on vast image data sets, the network itself extracts progressively more complex information, features from images, starting with low edges or low features in the earlier layers and cultivating high-level semantic features such as object recognition capabilities in deeper layers. This allows for the CBIR systems just to capture a more richer understanding of the image content compared to traditional methods. And the methods that we used for building our framework, first we started with the workspace station, where we developed all of our files, and then the visual feature extraction, to the distance measurement, where we used the Euclidean formula or equation, and from there we go to the QBE based or query by example based framework, where we basically put together our codes on MATLAB next to the target based images on the distance, and to the last where we basically figured out or tested our function. Here two really good examples of good and bad use cases or cases in general. Um, a user could input a picture of Michael Jordan playing basketball, and he'll get back 1,000 pictures of somebody in a Bulls jersey wearing number 23 that looks like Michael Jordan. But a bad case would be if someone were to upload a picture of, let's say, the New York City skyline, and they got back images matching the orange sunset and the black buildings below, but not exactly the skyline that they were looking for. And here's an example of the query-based, or the CBIR that we had, that I had built for this project, and the example. In conclusion, the main challenges that I really had faced was just the variation in image quality, and it was very difficult to input larger data sets in when testing the CBIR framework. Um, future, in the future, I believe that this framework will be honestly an algorithm that'll be used at the fingertips of everybody. It's a very efficient image retrieval system that really can exploit the large amount of data on the large amount of image data on the internet. And here are my references. And I will now begin the demo. Next, I will be going over the 5 functions that we have used throughout the semester to create the CBIR framework. The first one is create database, create DB. This one imports the images to get the distance calculated by the Euclidean distance between P and Q. Excuse me. Get hist counts. This one computes the histogram counts in the grayscale to a specific amount of bits. The next one, RGB26CC. This one simply converts RGB images into a 6-bit image. Get distance. This one just calculates the Euclidean distance between 2 points, P and Q, where usually the 2 vectors have to be of the same size. And CBIR, this is the main function that we have used. This one takes the images from the sample query size, and when we pick a random image, it matches up the next 20 most similar, as you will see when I run it now. And you see here, I can pick any image I want. Say I'm gonna pick Walter White. Let me see here. Here are the most similar images. You get the first 6, which are the same, and then the next ones, which are similar, and the next ones after that, which are similar. Thank you for listening to my presentation.